For reals. Next Wednesday is our last day in this unit, which means next Wednesday I'm going to give you all a take-home test that is due on Friday. We're not going to take this test in class because I don't want to lose any more days. The choice was either give you a review day or have you test in class. I would rather set you guys up for success with the review day. Okay? Tomorrow you are going to get a take-home quiz that's due Thursday. So the quiz is going to take you about 30 minutes, which is, yeah, let me say that again. You're going to get a take-home quiz tomorrow that is due Friday. The take-home quiz will take you roughly 30 minutes. You need to be able to set aside 30 minutes tomorrow night to do this.
So tomorrow night, Thursday.
Tomorrow night's Thursday, that's right. Right, and it's going to be due on Friday, and you're not going to forget to do this or not set aside enough time. And Polymon, you're going to make sure that you're looking over these journal entries, and Aaron will as well, so that like when you're writing up your justifications, they make sense to other human beings.
What counts as human?
Sometimes yes, sometimes no.
What is
All
that
right.
saying that you're a human being, just others?
Shut up, David. All right, so the homework is in the middle of the table, and your name is on it. Correction, some of you got a little note from me on the assignment that you turned in yesterday. The 3 problems on the back were really clearly labeled calculator inactive, meaning you were going to do like the number line test or something like that. If you didn't do that, I don't care if you marked it as being right, it's wrong. I couldn't do this without doing a number line test, neither can you. Tonight's homework, I want to make sure this is super clear. It's in the student packet. It's like the thing that we use in class every single day. Yep, the thing that you're going to find, and I think this is on what, like page 35 maybe? You guys are going to do student packet pages 37 and 38. It is all about number line stuff. You're going to take derivatives, you're going to find roots, you're going to build me a number line test, all the things. Okay? Everybody good? All right, so here is the plan. Here's the plan. I want to give you guys the first 2 minutes to read through this problem. We're on page 33. This is going to be almost exclusively a work period for you all. I know at the end of class yesterday we were graphing a function. We were graphing like the derivative of the function. And I said we'll finish that up today. We're going to leave that one as it is because I built those skills into this problem already. Okay? I'm like a ninja that way. So what I want you to do is take 1 minute. Read through this problem, mark it up, make this yours. We'll talk in a minute, and then you guys will have time to work in groups. And I'm thinking today the camera's coming over here. Just want to make sure you know. I was like, you can put the camera over here. I don't have time. 1 minute. Read through this problem, mark it up. This is exactly the kind of thing I would expect you to be able to do well in tomorrow's quiz. Because every single one of these things, justifications, including I'm taking this with me. The only thing I have to say, you wouldn't want to hear me say. Important things that we know about this problem from the reading. Important things that you want to make sure that you draw attention to so you handle this correctly. Carmen.
The graph is of
prime of X.
This is the graph of f prime of x. And if you are Siraj Birch, man, he was writing f prime everywhere. It is mission critical. It's not mission critical that you write f prime, it's mission critical that you know this is f prime. Other important things. Other important things about this graph. Celeste, what else do you know for sure?
F prime of x has horizontal tangent lines with x equals -3, 0, 5, and 5. And 2. Sorry.
Whoa, that was awkward. Alright, f prime has horizontal tangent lines at -3, 2, and 5. Right, so the reason I wanted to do that is I just wanted to make super clear that you understand what is happening on the graph of f prime at those 3 points. Another really important thing here, because you're never actually going to see, it's so hard to see. David?
Vertical tangent at x, isn't it?
Okay, and here's the thing, it is so hard to know for sure. I would be hard pressed to say by looking at this graph that I know there's a vertical tangent line. That's why I'm going to tell you, hey, there's a vertical tangent line over here. So if there's a vertical tangent line happening over here, probably there's going to be something special happening in the problem. And f prime has points of inflection at -5, 0, and 3. So we've got a POI over here, we've got a POI over here, and we've got a POI over here. Just like vertical tangent lines are hard to know with confidence where they are off of the graph, points of inflection as well. Because you might say, well, I'm concave down for a while, and then I'm concave up, but I don't know where the change happens. That's why I told you guys specifically POI at -5, and at 0, and at 3. With that, I want to give you guys the next like 8 to 9 minutes working in your groups. Just get some practice. You should be able to do A through F with minimal support from me. Alright, so we've got Aile on the left, David straight ahead, and Giselle to the right. These are some smart human beings.
What do you think is changing from positive to negative, right? What about this part though? The word change. Does it like a 2-point routine? Oh my God.
French toast. Nope. It's the roots. So at -5, 5, and 1.
Is it go positive, negative?
This is concave.
Oh, -5, yeah. -5 is the maximum.
funny.
Surprised you didn't just text me. Okay, so when does the graph of F have horizontal tangent lines? What are we looking for?
The roots of F prime.
Good. F has a horizontal tangent line, means F prime is over. So I can see from the graph, -5, -1, -5.
And then X equals 5.
You wrote though, F has a horizontal tangent line when F prime is 0. And you have to actually write that. Identifying them is good, but you have to have that justification. So at -5, do we have a relative max or relative min? Relative max, give me one.
Because
I think it's a saddle point because at it equals 0.
Love it. ILA, what's happening at -1?
It's a relative min.
Relative min and -1 because?
Because F prime changed from negative to positive.
Love it. Last one, Giselle, what's happening at x equals 5? At x equals 5, we know the derivative is equal to 0. Before 5, the derivative is positive. After 5, the derivative is positive. So is that a relative max? A relative min? It is neither. You could get fancy and call it a saddle point. But the question is asking, is this a relative max, is it a relative min, or is it neither? It's neither. All right, let me come back over here. Are you good? Now, one thing I should share with you. Questions where it asks about a horizontal tangent line actually becomes why. So like F has a horizontal tangent line, what is this? For F to have a horizontal. Where F prime is equal to 0, you have to actually physically write that. F has a horizontal tangent line, means F prime is equal to 0, and you can put it into that. And then, -5, -1 positive. You need to make sure that you're answering the positive. And then if you guys do that, and max at -5.
Give down. F prime of x. Oh, and decreasing.
Careful, you're right at the saddle point, read that question.
You have a really bright yellow paper.
Okay.
Right, you gotta be super careful that you are reading the question.
I still have sign on.
Okay, friends over here, how are you?
Question.
Yeah.
X equals 5? Is that a saddle point?
It is a saddle point. Tell me why.
Because F prime of X equals 0, but it doesn't change anything.
But F prime is no sign. The derivative is equal to 0, but the derivative doesn't change sign. But here's the thing. Look at their question. What are they asking?
So,
Right, is this a max? Is it a min? Or is it neither? Saddle point is
no, because
mathematically correct,
it's not negative.
but this statement is looking
So
for
it-
max
there's no place.
and neither. These are your three choices.
So we just find the max and.
And you have to say that x equals 5 is neither. Okay.
so
Alright, B, if F is concave up, what are we looking for?
I'm just increasing.
If F is concave up, F prime is increasing, first point. Interval where that happens, -3 to 2 and 5 to 7.
Yes.
Second point, love it. Alright, I want to move you guys over to part C. Identify all intervals in which F is concave down and decreasing. So if F is concave down, F prime is decreasing. And I also need F to be decreasing. So F prime has to be negative. So you're looking for, on this interval, where is F prime decreasing and negative? Right, so that should be from -5 to -9.
X equals 2, right?
But I have yet to see
And then
something like
X
this.
equals
F is
4?
concave down and decreasing. Means F prime is decreasing and negative. Without that, at most I can get
I think so.
Right? You guys are seriously doing a good job. Just make sure that you're always connecting what they're looking for to the graph that you have up here. Right now, we're just focusing on FF prime stuff. More is coming. Don't be absent.
I'm paying that.
You guys decide for yourself.
So get that. I'm absent.
Get down and
I'm decreasing. You don't need to.
But hold on, what are we looking for? F is concave down and decreasing, so F prime has to be. Guess what? That's the one I got that. F is two things. F is concave down. And the same column, can I turn it off? If F is concave down and decreasing, then F.
Oh, negative 3, right? And the equation of
Decreasing, but you actually need to, right?
Okay, so
Instead of like adding weight, so you've got the right interval, negative 5 to negative 3. But getting the right interval, getting that right answer is what the one. Just
Negative 3 is negative 2.
I get it.
All right, spoilers, here come the answers for A, B, C, and D since I had a chance to walk around and talk to everybody about Part A. The only thing I want to say about Part A is this. They're asking for horizontal tangent lines. You must make a statement somewhere that says, oh, F has a horizontal tangent line, means that F prime is equal to 0. With all of these problems, every single part, you've got to connect it back to what you know about the original graph. Part B, if F is concave up, F prime is increasing, would be 1 point. The interval is negative 3 to 2 and 5 to 7 is the second point. Part C, where is F concave down and decreasing, that means F prime is decreasing and negative, 1 point, that's the justification point. Negative 5 to negative 3 is the second. Okay, if you have points of inflection, let's get some hands on this. F has a point of inflection. What am I looking for, David?
We're looking when F prime changes increasing to decreasing, or it changes from decreasing to increasing.
Perfect. If F has a point of inflection, F prime changes from increasing to decreasing or decreasing to increasing, give me both. And then identify where that's happening. Where that's happening should be at x equals negative 3 and x equals 5. As well as at x equals 2. Pretty good? All right, there's two parts that I really care about. Parts F and G. On part F, what I'm going to ask you to do is take the next 1 minute, completely on your own. Show me what you can do with part F, and then we'll do part G together. And then the bell's going to ring, and it's going to be sad.
I know.
It's going to be time to go to like other classes. Oh, bummer. If you didn't get a chance to do part E, here's what you need to know. Steven! Steven! Hi. Here's your camera back. I thought we were capturing all that good stuff. No, we were capturing this good stuff over here, these three.
Oh, I see.
That even Steven Spielberg, you know, gets to do some retakes. Okay, can you see that? Okay, what I really mean is, can the kids at North Central see what I'm talking about?
Yes.
Good, I'm glad that you can see. All right, part E. I told you that f of negative 3 is equal to 4. The only thing that you're missing is the value of f prime of negative 3, which is negative 2. I'm going to get that from the graph. My tangent line says L of x equals negative 2 times x plus 3 plus 4. Hopefully that's pretty straightforward. But this is the tangent line that you need to address what's going on in part F. We'll talk a little bit. Part F is worth 3 points.
We don't have to. Okay.
What was that?
No.
Never. Okay. If we're talking about the free response part of the test, no need to say. I checking out yesterday. Alright, if I'm going to figure out f of negative 2.8 using my tangent line approximation, all I need to do is plug it in. So f of negative 2.8 is approximately what we get by L of negative 2.8, which is negative 2 times negative 2.8 plus 3 plus 4, getting that 1 point for the OCD friends in the room. Negative 2.8 plus 3 is 0.2 times negative 2 is negative 0.4. If you simplify, you're going to simplify to 3.6. There is no need to simplify. All that you can possibly do is throw away a point that you've already earned, so don't do it. All the friends okay? So now the important thing, underestimate or overestimate?
Underestimate.
Over.
Either answer just alone gets you no points. You have to justify this. So is 3.6 an overestimate or is 3.6 an underestimate? I need to look at my graph, and you need to be able to, using the graph, tell me about the concavity of F. Well, what do we know about the graph? My point of tangency is at x equals negative 3. The point that I'm estimating is at negative 2.8. You need to tell me something like from negative 3 to negative 2.8. From the point of tangency to the point that I'm estimating, what do we know about f prime? What's f prime doing?
Increasing.
F prime is increasing. That's nice. What does this tell us about f?
It's called
F is concave up. Now stop and think about this, because this is where you're going to go wrong. If F is concave up, all those tangent lines, all the tangent lines are below the graph. If you're not sure, like draw it on the side. Concave up, here's a tangent line. Hey, that tangent line too. They're all going to be below. So F is concave up, tangent lines are below the graph. So what's your conclusion, Polymon? Below the graph of F, therefore an underestimate. So whoever said underestimate, yes, you were right, but if all you say is underestimate, they're not going to give you any points, and neither am I. You have to mention your point of tangency. You have to mention the point that you're estimating, and what you're saying better be true. From negative 3 to negative 2.8, I can see from my graph, F prime increases, which means F is concave up, tangent lines are below. That gets me an underestimate. All of this here would be worth 2 more points. David? I thought you had a question. Is everybody good with this estimate question?
Mm-hmm.
Usually, on the first quiz, like 10% of students get it right. I'm just saying. I'm just saying. Good luck, Carmen. I need you. I am sure there are lots of smart cookies in my cookie jar that are going to be able to get this right. All right, we got about 7 minutes left. Here's the goal. We are in this together. I'll get the lifesavers. You have in front of you the graph of F prime. What I want is the graph of F double prime. I want good, accurate things about the graph. When you think you can tell me something for sure about F double prime, raise your hand. Myra.
F double prime has a slope of 0 at x equals negative 3 on F prime.
Okay, so for me, the black is going to be F prime. You might want to grab the markers out of the container there. And the green is going to be F double prime. Myra, one more time, I get a little distracted. What did you tell me about F double prime? At x equals 3?
Negative 3.
-3. So at x equals -3, I can see f prime has a horizontal tangent line, so that means I must have a root. F double prime has to have a root. Not only does that happen here, but all the places, right? I got a root, and I'm gonna have to have a root. Nice job, Myra. I like starting with the roots because it's the thing I can say with certainty. Oh, Steven, you are so... Are you having girl problems? Oh, I'm sorry. Okay. Steven is so distracted. Apparently, I have to do all the heavy lifting here. Horizontal tangent lines on f prime mean roots of f double prime. And the reason I like starting with the roots is I now have a point that I know for sure that's on the graph. And I can start using this to my advantage. Are there any other things we know for sure about f double prime? Palomon.
From -7 to -3, since f prime is decreasing, it's going to be less than 0.
Okay, from -7 to -3, I see that f prime is decreasing, which means f double prime is going to be below the x-axis. Good, that's a thing that we know for sure. Now the tough part is I don't necessarily know how to draw below the x-axis. There's a lot of things that I could be doing here. Okay, but here's something else. It is true that from -7 to -3, f prime is decreasing. But I told you guys about points of inflection earlier as well, I think. There was a reason for that. And was the point of inflection over here at -5? So there's something else about f prime that's true on this interval. F prime is decreasing, but you can also tell me about concavity here. What do we know about the concavity? From -7 to -5.
Concave down.
Concave down. So think about this. From -7 to -5. I'm not drawing that like an asymptote, I'm just drawing that to like focus the attention. From -7 to -5, f prime is concave down and decreasing. So f double prime, the thing that I want to draw, f prime is concave down, f double prime? Has to be decreasing. If f prime is concave down, then its derivative is decreasing. And f prime is decreasing, so this means negative. So I need to draw decreasing and negative from -7 to -5. I'm just going to draw something, maybe like, what do we need? Decreasing and negative? Maybe something like that. It doesn't have to look exactly like this, as long as what you draw is decreasing and negative, we're good. After -5. From like -5 to -3, the things that we know.
F prime is concave up.
F prime is concave up and?
Negative.
And, uh-oh.
Decreasing.
And decreasing. So if f prime is concave up and decreasing, then what I have to draw is f double prime is, if f prime is concave up, then this guy's derivative is
Increasing.
increasing. F prime is decreasing, so f double prime is
Negative.
negative. I need to be increasing, negative, and hit a root. Everybody okay? Alright, see what you guys can do from -3 over to your next point of inflection, which is it x equals 0 is your next POI?
Yes.
Okay, see what you can do again there. Alright, for the friends at home, from -3 to 0, f prime is increasing, f prime is concave up. So f double prime must be positive and increasing. So positive and increasing ought to look something like that. How many of you guys had that on the interval -3 to 0? Positive and increasing? Okay. How about this next interval from your point of inflection until this next point? F prime is two things. F prime concave down and and increasing, so F double prime. F double prime should be decreasing and positive. So decreasing and positive, and I'm gonna hit that root, decreasing and positive. Now I wanna focus on right over here. If we don't finish anything else, I wanna focus on this last point of inflection. There's something we know that happens at x equals 3. We know we have a, not an asymptote.
Vertical tangent line.
You have a vertical tangent line on F prime, which means I know something about F double prime,
F double prime is X.
right? If F prime has a vertical tangent, then F double prime has a vertical asymptote.
Excuse me,
Yep.
there may have been a mistake in your work, as there is a root on x equals -1, meaning
One more time.
at x equals -1,
At x equals -1,
it's supposed to be a horizontal tangent line on
there's supposed to be a horizontal tangent line at -1.
at f prime, on f prime.
F prime at -1? No.
Isn't it supposed to be like flat at the top?
No, if F prime, if the black graph has a horizontal tangent line and the green graph has a root.
Oh wait,
So horizontal tangent line at -3, horizontal tangent line at 2, horizontal tangent line at 5. Just to finish this up real quick, we are decreasing and concave down. So I need decreasing and negative, honoring the fact that I have a horizontal, vertical asymptote, and decreasing and negative. Afterwards, F prime is increasing and concave up. So F double prime is, we're decreasing and concave up, so that means that the derivative is negative. And increasing, negative and increasing, looks something like that. From 5 to 7, we are increasing and concave up, so positive and increasing, and I'd stop there. All right. Tonight's homework is just using the number line test. You guys should be good. I will see you tomorrow, and I get to do